guys, welcome back. Today we are going to be talking about section 1 of our new chapter, chapter 11, and it's specifically talking about sequences of functions. So this first few things are just some definitions for you, but a sequence is a set of numbers in a particular order or pattern, and each number is going to be called a term. And then we have two types of sequences. We either have finite or infinite. Finite just means it has limited number, so you'll notice in those that it does not have any dots at the end, it just stops. Where infinite is going to continue without end, and to show that, we show it with the 3 dots right there. So the first type of sequence we're going to be learning about how to solve for is an arithmetic sequence, and this is when each term is determined by adding a constant value to the previous term, and that constant value is called the common difference. Now, if you remember, difference means subtract, so it is okay to add or subtract. It's just talking about how much is it changing by each time. It is okay to get larger or smaller, but you'll either add or subtract that value. Okay, so for our first example, we're going to be identifying if it's arithmetic or not. So again, we're looking specifically, are we adding or subtracting by the same value? So what you do is you think from 7 to 12, well, I would have to add 5. From 12 to 16, I would add 4, and 16 to 20, I would add 4. If these are exactly the same, they have a common difference, meaning yes, it's arithmetic sequence. So since we have a 5 and then 2 4s, these do not all match. So this answer would be no. For our second one, we have -6, 3, 12, and 21. From -6 to 3, that would be adding 9. 3 to 12 is adding 9. 12 to 21 is adding 9. Again, you're just figuring out that pattern. What am I adding or subtracting by? This time, since all 3 numbers were the same, that is a common difference. So this one would be yes. Also, just to point out what we were talking about a minute ago, infinite having the 3 dots, both of these show that. So these would both be infinite if you needed to know. Okay, so for our next example, rather than just finding out what the common difference is and saying yes or no, we're going to actually find the next 4 terms it says. So what I like to do is I'll look at my pattern, but I go ahead and I draw 4 blanks because sometimes it might say 3, sometimes it might say 4. So I always like to start off just kind of getting my problem set up. And then I'm noticing these are going down, so subtracting. So 18, what would we subtract by to get to 11? So it'd be -7, and again, I need this to match, right? So that it actually is an arithmetic sequence. So 11 minus 7 is also 4. So our common difference is -7. And you might write that by saying D equals -7. So then all we need to do is just subtract 7 and we keep going. So 4 minus 7 is -3. Minus 7 is -10. Minus 7 is -17. And -7 is -24. So our next 4 terms are -3, -10, -17, and -24. Okay, so our next question is a word problem, and it says Geraldo's employer offers him a pay rate of $9 per hour with a 15-cent raise every 3 months. How much will Geraldo earn per hour after 3 years? So we're going to start off with the $9, and then we're going to add 15 cents every 3 months. So we have 3, 6, 9, 12, that's 1 year. 3, 6, 9, 12, that's after year 2. 3, 6, 9, 12, that's after year 3. So this price would be what we're going to get for that. So I'm just quickly going to add 15 cents and let y'all watch what our final price is. So our final price is going to be $10.80. So after 3 years, every 3 months getting that 15-cent raise, Geraldo will be making $10.80. Okay, so our next type of sequence is a geometric sequence, and this time is just whenever you multiply or divide to get the next number, and that constant value that you're multiplying or dividing by is called the common ratio. So one thing I wanted to show you with this is you're going to notice that with a geometric sequence, you can have a sign change back and forth. If you're adding or subtracting, you can only have one sign change, because if you added 3, you might start off with a negative and eventually get positive, but you're not going to go to a negative number if you're adding. So if you ever see a negative, positive, it's a good chance it is geometric. You still need to check that it multiplies by the same number or divides by the same number, but it's a good chance. So we have -8 and then 2. So what I would suggest is you take -8 and you divide it by 2, and that's -4. So the idea is that we probably divided by -4. So -8 divided by -4, that's 2. Divided by -4, that's -0.5. Divided by -4, that's 0.125. So all of these did divide by -4. So since they divided by the same number every time, you would say, yes, this is a geometric sequence. You also could think of it as multiplying. So if you did it this way, you would say 2 divided by -8. You take the second term divided by the first term, and that'll tell you how much to multiply by. So you could just multiply by -0.25, and that would get you the same answer. Times -0.25 times -0.25. And really, that's probably the better way to do it. You can do it either way. At this point, we're just saying yes or no, so it doesn't really matter which way you think of it. When we get to further into this chapter though, that common ratio is specifically what's being multiplied by. So that -4 we're getting wouldn't be the common ratio, it would be that -0.25. What did we multiply by, not what did we divide by? Okay, for the second one, hopefully it pops out pretty easy that it does not divide by the same thing, because 1 times 3 is the only way to multiply and get to 3. And if you did 3 times 3, that would be 9, not 7. So this one will be no. It does not multiply by a common ratio. For our next example, we're just going to find the next 2 terms. So again, I like to go ahead and set up blanks for however many they asked me for, and since it was 2, then I'm going to look and see, okay, well 7 times 3 is 21. Is 21 times 3 63? Yes. So my common ratio is 3. So then I'm just going to keep multiplying. So I'd have 63 times 3, and that's 189. And then 189 times 3 is 567. So those would be the next 2 terms. Okay, so for our last example, our job is to determine if it's arithmetic, geometric, or neither. Remember, arithmetic meaning we add or subtract by the same number, geometric, multiply or divide by the same number, and then if it doesn't do either, we would say neither. So one thing I noticed here is we have over 3, over 3, over 3. Well, this 2 right here, let's rewrite that as a fraction over 3. So it would be 2 over 1, and then times 3 would be 6 over 3. So then if you notice, the top is just adding 1, adding 1, adding 1. So what we're doing is we're adding 1/3 plus 1/3 plus 1/3. So that common difference is positive 1/3 that we're adding by, and this would be an arithmetic sequence because we added by the same number. For our next one, again, you'll notice that some of them are fractions, some of them aren't. One thing I noticed really quickly was this is a positive, negative, positive, negative. If the signs change multiple times, it cannot be arithmetic. The only thing it could possibly be is a geometric. So what I'm going to do is I'm going to take that second term, which is -3 over 2, and I'm going to divide it by the first term, which is 2. And I get -3/4. So the idea would be we were multiplying by -3/4. So 2 times -3/4 is -3 over 2, which we already knew that's going to match, times -3/4, and we get 9 over 8, which matches. And then one more time, times -3 over 4, and we get -27 over 32. So that common ratio, we're multiplying by -3 over 4, and this would be a geometric because we multiplied by the same value each time. Again, that trick I was using is I was doing the second term divided by the first, and that'll help you find that common ratio here, and then you just keep trying it on all of them to see if it works. The last one again is negative, positive, so it cannot be arithmetic because there's no way to change signs twice if you're adding or subtracting. So to get from -4 to 4, that'd be times -1. And if I multiply 4 times -1, that would not be -5. 4 times -1 would be -4. So on this one, it would be like it was subtracting, and then it would multiply again. So this one doesn't follow the same pattern for every number. So we would say neither, because there's not a number we're either multiplying by or adding by each time to make that pattern.